When we have a solid precipitate and ions still in solution, we have a dynamic equilibrium. This equilibrium is quantified by its equilibrium constant. And this equilibrium constant is called the solubility product constant. The solubility product constant is given the symbol Ksp. It is defined for an equilibrium where an ionic compound is dissolving in the forward process. Precipitation would be the reverse process. So if we wanted to write an expression for Ksp for silver chloride, the appropriate balanced equation would be AgCl as a solid going to form Ag1 plus ions and Cl1 minus ions as products. Writing an expression for this equilibrium constant, we would have Ksp equals the concentration of silver ions times the concentration of chloride ions. Remember that liquids and solids do not appear in expressions for equilibrium constants, so silver chloride does not appear. If we wanted to write an expression for Ksp for lead-2 chloride, the balanced equation we would use is PbCl2 as a solid going to aqueous lead-2 plus ions and 2 moles of chloride ions. So the expression for Ksp would be Ksp equals the concentration of Pb2 plus times the concentration of Cl1 minus squared. If values of Ksp are available, it allows us to compare the solubility of different compounds. However, without a calculator, we can only compare compounds of a similar charge type. For example, if we're given the following information, Ksp for silver chloride equals 1.8 times 10 to the minus 10th power, and Ksp for silver bromide equals 5.0 times 10 to the minus 13th power. We could ask, which is more soluble? Remember that the equilibrium constants are for the solids dissolving. The larger equilibrium constant belongs to silver chloride. 10 to the minus 10th is larger than 10 to the minus 13th. A larger equilibrium constant means more products, which in this case means more ions and a more soluble compound. As a caution, this only works if the charge types are similar, as in this case where they are both 1 plus, 1 minus ion combinations. If you were trying to compare silver chloride with lead-2 chloride, you would need to go to the calculator because lead-2 chloride has chloride squared in its expression for Ksp. We'll save those comparisons for a later course. But note that you could compare lead-2 chloride with barium chloride by this method, since they are both 2 plus, 1 minus charge combinations.